Hey there, parents. Welcome. Today, we're jumping right into a visual explainer of the wCode curriculum architecture. If you're looking at enrolling your child in the wInstitute's wCode program, you're about to see exactly what their educational path is going to look like. We are going to trace this incredibly comprehensive, highly structured 13-year journey that takes a child from basic problem-solving in kindergarten, literally all the way to professional engineering in high school.
Because let's be honest, it's the ultimate question, right? What is your child actually going to be capable of building by the time they hit 18? I want you to hold on to that thought. We're going to trace the exact steps of how a 5-year-old who starts out just playing with a physical robot mouse transforms into a 17-year-old deploying full-stack web applications backed by real data science. It sounds like a massive leap, I know, but as you'll see, it happens through a very deliberate, step-by-step progression.
Okay, let's dive into this. Here is our roadmap. We'll cover our welcome, the early makers from ages 5 to 7, junior innovators from 8 to 10, middle explorers up to 13, teen visionaries up to 18, and finally, what the ultimate wCode graduate looks like. All right, let's start right at the beginning.
Section 1, Early Makers. This is for ages 5 to 7, so we're talking kindergarten through 2nd grade.
The primary focus here is building the foundational mental model of programming, but we're not relying on screens right away. Their official theme is, I am a thinker and a maker, and I just love that. Kids at this age learn to sequence commands and debug errors using physical, tactile toys. They're getting their hands on things like the Code and Go robot mouse and the logical road builder puzzle. It's only after mastering those physical logic steps that they move over to a screen, where they start using block-based coding and Scratch to build fun interactive animations.
Now picture this. At the end of this division, you get to attend the Creators Gallery capstone event, and these deliverables on screen are what you will actually see your 7-year-old present. You'll see a digital storybook that they narrated themselves using a USB microphone, a digital animation they coded entirely in Scratch, a stunning choreographed light and movement performance using a programmable Sphero Bolt robot, and, this is super cool, the very first 3D object they designed in Tinkercad, printed right in-house. It's all about translating these new tools into tangible, incredibly creative projects.
Moving right along to Section 2, Junior Innovators, ages 8 to 10, covering grades 3 through 5.
This division is a massive milestone because real text-based programming officially begins. Their theme evolves to I code, I build, I create, and this really anchors a child's growing identity as an inventor. They aren't just playing with robots anymore, they're actually inventing physical controllers. They use a tool called Mickey Makey to wire everyday objects into game controllers. They build their first real web pages using HTML and CSS, and they even train their first artificial intelligence models using just their tablet cameras.
And this brilliantly illustrates the shift that's happening. The contrast between these stages is honestly staggering. Think about it. Division 1 was all physical objects and block-based logic. But here in Division 2, the training wheels come off. Python officially replaces the blocks. This is a crucial transition where students move away from just dragging and dropping commands, and they start writing their very first text-based Python code, learning real syntax, variables, loops, and functions.
To give you a sense of how that technical complexity increases gently over time, let's take a look at the drone programming track. At age 9, they learn FAA safety rules and fly the CodeDrone EDU manually using Blockly commands. But by age 10, they are writing Python to command that drone to take off, hover, and land completely autonomously. They aren't just using a remote control, they are actually writing the code that flies the machine. And by age 11, they are writing code for a full 3-waypoint autonomous route. As parents, you get to watch these live drone flights at this division's capstone event, the Innovation Expo. It's a blast.
Section 3. Middle explorers, ages 11 to 13, so grades 6 to 8. At this age, the focus shifts heavily toward intermediate and advanced mastery. They aren't just learning concepts for the sake of it anymore. Every single domain they study has to produce a real working output. Their theme is, I solve real problems. They are combining their skills to interact with the real world. For example, they use the Zoomy self-driving car, which is powered by a tiny microcomputer called a Raspberry Pi. Students write Python algorithms to use Zoomy's infrared sensors for line following and its camera for object and color recognition. So they are quite literally writing algorithms for autonomous vehicles.
The outputs for their capstone event, the Pioneer Showcase, are incredibly impressive. Just listen to these deliverables. They are launching a live, responsive, multi-page website to a public URL using advanced JavaScript. They're demonstrating an AI model they built from scratch using Python.
They run a real 4-week brand campaign using professional green screens and ring lights, and then they report on their analytics. And using Fusion 360, they design a multi-part functional 3D prototype and actually pitch the business model to an external panel, totally Shark Tank style.
All right, on to Section 4, Teen Visionaries, ages 14 to 18, grades 9 through 12.
This is where students achieve professional-grade mastery across all 7 of the program's domains: coding, 3D printing, drones, web development, AI, social media, and ethical hacking. Their theme is, I Change the World, and it really represents real-world integration. These high schoolers aren't just doing classwork anymore. They are executing real deployments, filing real cybersecurity bugs, and launching real products. They are transforming into industry-ready visionaries who can immediately add value in the tech sector or absolutely thrive in top-tier university programs.
Let's move to a specific track and see how this builds, using ethical hacking as our example. At 14, they practice beginner network defense and scanning. At 15, they move to Kali Linux, conducting formal penetration testing, which is essentially learning how to legally hack into sandbox systems, and they write professional vulnerability reports. By 16 and beyond, they are participating in professional bug bounty programs through platforms like HackerOne or BugCrowd. They are finding and submitting real-world flaws for actual companies. It is just an amazing evolution of skills.
When these teens finally step on stage at the annual wCode Summit for their final capstone, they present a robust, professional portfolio. They show off a deployed full-stack web application with user authentication and a functioning database. They demonstrate an AI neural network they built using TensorFlow or PyTorch, deployed as a live API. They screen a complete film shot by a drone that they programmed to fly autonomously using OpenCV computer vision. And they leave with a professional GitHub portfolio hosting all of their code. Make no mistake, these are resume-ready, professional assets.
Which brings us to Section 6, the ultimate wCode graduate.
Now, what's really interesting about this slide is seeing exactly what a child achieves over 13 years. The direct comparison between a student's starting point and their exit capabilities is frankly jaw-dropping. In coding, they start at age 5 sequencing a little plastic robot mouse. They exit at 17 building full-stack apps with data science. In 3D printing, they start at age 7 making simple Tinkercad nameplates. By 15, they're engineering advanced Fusion 360 products and pitching them for sale. In AI, their first touch at age 8 is a simple tablet camera image classifier. By 14, they are deploying live neural networks.
So how do they get there? Well, the curriculum is highly structured and incredibly reliable. Over the course of their journey, your child will systematically earn 48 distinct badges, and in doing so, they'll master 18 critical hardware and software tools. We're talking about everything from Makey invention kits and Vex IT robotics, all the way to Raspberry Pi single-board computers, Kali Linux, and professional audio-video production suites. It is a rigorously designed path that absolutely guarantees exposure to the full spectrum of modern technology. At the end of the day, the wCode curriculum isn't just about teaching a kid how to type code. It's about building a foundational identity as a maker, an innovator, a problem solver, and ultimately a visionary. I hope this explainer has given you a really clear, exciting picture of the long-term value of this incredible educational journey, which leaves us with one final, provocative question to think about. Is your child ready to change the world?